In this tutorial we are going to learn about ethanol distillation. So we are going to perform a mass balance calculation on a distillation unit. Before going to the problem, I'm just going to quickly revise what's the mass balance, and I'm going to give some few tips like how to perform a mass balance on any unit operation. So these are few things that you must remember whenever you're going to perform a mass balance calculation. You have to remember the law of conservation of mass, which is that nobody can destroy the mass. So mass is always conserved. So if you have some system where something is happening, so say you put some compound A and you take two streams, compound B and compound C. If you load 10 kg inside, and if you take 5 kg of product B, so the product C must be equal to 5 kg. So what it mean, like if your input is 10 kg, your output is 10 kg, which is 5 plus 5 kg. So what it states is like mass is, at the end of the day, your mass is conserved. So this is a must rule. Nobody can destroy the mass. So if you put some 1 kg, you get 1 kg. So that's the rule. So you must remember this law of conservation of mass. Yes, and then again this. So if you have two input streams and then you have one output stream, say A, B, and then your output stream is C. Say this is some process where something is happening, so where you are converting your A plus B into C. So if you load 10 kg and say you loaded 5 kg of your B into the reactor or to the system, you must get 15 kg out. So at the end of the day, your mass is conserved. So what is like A plus B is equal to C. So these are some basic rules, and again few more things. Consider you have some system where something is happening. Say you put one stream A that contains 10 percentage of so let's call this as input stream that contains 10 percentage of A, and then say remaining 90 percentage of B. And say like you have two output streams from the system, say like output 1, say this is output 2, and so something is going inside input stream, say 10 kg per hour, and say output stream 1 comes at 5 kg per hour. So 5 kilogram of mass comes out for every 1 hour. So which means your output 2, which must be equal to 5 kilograms per hour, the mass flow rate from output 2. This is the second output stream, and this is your first output stream. It must be 5 kg per hour. Why is that? It's always like this. We call it as a flow balance. Flow balance, it should be equal to in is equal to out. So in this case, input mass flow rate is 10 kg per hour that goes inside. That should be equal to the mass flow rate in output stream 1 plus output stream 2. So this is 5 kg per hour, and this is 5 kg per hour. So 10 kilograms per hour goes into the system, 10 kilograms per hour comes out of the system in total. And then coming back to this same problem, I said in the input stream you have 10% A, and just imagine in the output stream you have 5% A, and in the output 2 stream, so how much percentage of A? If we need to calculate, we call this as a component balance. So now we are going to perform a mass balance on one component, which is A. So how to perform mass balance for one component? So we have the system. So I said 10 kilograms per hour goes inside. So out of this 10 kilograms, only 10% is compound A. So which means 10 multiplied by 10 by 100. which means only 1 kg. 1 kg of A goes per hour. So for every 1 hour you are supplying 1 kilogram of compound A. So that's the meaning of that. And as I said, you have two output streams. One is output 1 and output 2, and we know this one is 5 kilograms per hour and this one is 5 kilograms per hour. That's a mass flow rate. So mass flow rate is like how much mass flows into the system per unit time. In this case I expressed time in terms of hours. It can be minute or seconds. And then I said 5% of the stream contains compound A. So we know output 1 flow rate, mass flow rate is 5 kilograms per hour. So what is 5% of 5 kilograms per hour? That's equal to 5 kilograms per hour multiplied by 5 by 100. So how much is that? 5 5s are 25 by 100. You supply 5 kilograms per hour. That's correct. Let's calculate again. 5 kilograms per hour, that's your output stream 2, and 5% of this is your compound A. So 5 by 100, so that's equal to 5 5s are 25 by 100. That should be equal to 0.25 kilogram per hour. So your compound, the the mass flow rate of compound A in stream 1, it should be equal to 0.25 kilograms per hour. So what will be the mass flow rate of compound A from output stream 2? As I said to you, like if something goes in, that must comes out. So here you have 5, how many kilograms goes inside? Exactly 1 kilogram of A goes per unit time, and you know in the output stream you have 0.25 kilograms per hour. So we have to calculate how much comes in the third stream, in the second output stream. Sorry, we know it's 5 kg per hour. So we have to perform a simple component balance. It's really easy to perform. So what we do is like, your total mass flow rate, which is 5 kg per hour multiplied by 10 by 100, that something goes in compound. So this is for your input stream. It's equal to output stream 2, that should be equal to 5 multiplied by 5 by 100 plus 5 multiplied by x by 100. So what is this value? You have 10 kgs that goes inside. So this is 1 kg per hour, 0.25 kg per hour plus 5 x by 100. So x is something that we need to find. So how 1 minus 0.25, that's equal to 5 by 100. So 0.75 multiplied by 100 by 5. So that should be your value. Point 25 5 by 100 is 5 is at 25.25. 5 multiplied by x times by 100. minus 25 is 0.75 by, that should be equal to 75 by 5. Now there is some mistake, there is clearly some mistake.